So in this lesson, we will learn how to compute the limit of a function using the limit theorems. So today, we will be discussing 8 types of theorems.
Limit theorems. First, limit of a constant theorem. Second, limit of a function x. Third, limit of a constant in a function f of x. Fourth, limit of sum and difference of a function. Fifth, limit of a product of a functions. Sixth, limit of a quotient of functions. 7. Limit of a power of functions. 8. Limit of a root of a functions. First theorem. The limit of a constant itself. If k is any constant, then the limit of a constant as x approaches c is equal to a constant. Example, limit of negative 3 as x approaches 4 is equal to negative 3. Since our constant is negative 3, so the limit is negative 3. Second, limit of 2/5 as x approaches 1/2 is equal to 2/5. Since our constant is 2/5, the answer is 2/5, 3. The limit of a function pi as x approaches 3 is equal to a pi. Fourth, limit of 8/8 as x approaches 4 is equal to 8/8. Since 8/8 is our constant, then the limit of the function as x approaches 4 is 8/8. The same as number 5. So the constant there is pi over 5. Therefore, the limit is pi over 5. 6. The limit of a function square root of 2 as x approaches 3 is equal to square root of 2. You have to remember that the limit of a constant as x approaches to any constant is always equal to the given constant. Our second theorem is the limit of a function x. The limit of a function x as x approaches c is equal to c. Therefore, symbol, the limit of our function x as x approaches c is equal to c. Example, limit of x as x approaches 1 is equal to 1. Since our function is x and x approaches 1, therefore the answer is 1. 2. Limit of a function x as x approaches negative 1/2 is equal to negative 1/2. Since our function is x and our constant is negative 1/2, the limit is negative 1/2. 3. Limit of x as x approaches 3.25 is equal to 3.25. Since our function is x and the constant is 3.25, the limit is 3.25. Fourth, the limit of x as x approaches 2 is equal to 2. Since our k is 2, the limit is 2. Fifth, limit of x as x approaches pi, the answer is pi. Since our k is pi, the limit is pi. 6. The limit of a constant x as x approaches 6.33 is equal to 6.33. Since our k is 6.33. I hope you get it. You have to remember that the limit of a function x as x approaches to any constant is always equal to a constant. That is theorem number 2. Number 3, limit of a constant and a function x, like a combination of the first and the second theorem. Constant and a function f of x. This says that the limit of a multiple of a function is simply the multiple of a limit of a function. So, the limit of c, which is a constant, of f of x as x approaches k is equal to c, the limit of a function x, f of x, as x approaches k. So, it's like you move the constant in front of the limit. And this will happen. You have to remember that in evaluating a limit of a constant in a function, the following steps can be followed. First, express the limit as a product of a constant and the limit of f of x. Second, find the limit of a function x based on the given value for x. And third, you have to simplify the resulting numbers. Let's have an example. Limit of 3x as x approaches negative 2 is equal to, as you can see, the constant here is 3, so you have to move forward constant, and then try to notice, I go back to number 2 theorem. The limit of x as x approaches constant. We are given 3 times the limit of x as x approaches 2 is equal to, you simply copy the constant, which is 3, and then in simplifying limit x as x approaches negative 2, it gives you negative 2. Then you have to simplify it. 3 times negative 2 is negative 6. I hope you got it. Number 2, limit of negative 6x as x approaches 1/2. Okay, in the problem, the constant is negative 6. So you have to move that in front and then go back to theorem number 2. Okay, so negative 6 is in front already. So the limit of x as x approaches 1/2. Simplify the limit of x as x approaches 1/2, gives you 1/2. And then negative 6 times 1/2 is equal to negative 3. Okay. And last sample for theorem number 3, limit of 5x as x approaches 1/25. So our constant here is 5, so you move front the 5 and then go back to step number 2. Simplify limit of x as x approaches 1/25. The answer there is 1/25, and then you multiply 5 by 1/25, and that gives you 1/5. I hope you understand. As you notice that we keep on reviewing the first and the second theorem, so you have to bear with those theorem because at some point you're going to use it. Okay, let's have number 4 theorem, limit of sum and difference of a function. This says that the limit of a sum or difference of function is the sum or difference of the limits of the individual function. Limit of f of x plus or minus g of x as x approaches k is equal to limit of f of x as x approaches k plus or minus x. Limit of g of x as x approaches k. So it's separated for as long as there is operation between the two functions. And you have to remember, in evaluate the limit of sum and difference of a function, the following steps can be followed. First, express the limit as a sum or difference of a function depending on the number of terms. 2. Apply the previously discussed limit theorems in finding the limit of each term. And 3. You have to simplify the resulting numbers. Let's have an example. Limit of x plus 5 as x approaches negative 2. So you have to separate the x and the 5. So in separating this, limit of x as x approaches negative 2 plus, since the operation between them is plus, limit of 5 as x approaches negative 2. Simplify. Take note that the limit of x as x approaches negative 2, this is second theorem. So our constant is negative 2. Simplify, that's negative 2. And limit of 5 as x approaches negative 2, this is number 1 theorem. So you simply copy the constant 5. And then simplify what is negative 2 plus 5, it gives you 3. Number 2, limit of 4x minus 2 as x approaches 5. The same thing is like number 1, you have to separate 4x and then the negative 2. Take note that this is theorem number 3 before x. So constant 4, move forward, become for limit of x as x approaches 5. So that's theorem number 3. Minus, the operation between them is minus. So limit of x as x approaches negative 5. To simplify it, Okay, limit of x as x approaches negative 5 gives you negative 5. Remember theorem number 2. So 4 times negative 5 is negative 20. Then copy negative 2. Negative 20 minus 22, it gives you negative 22. Okay. Sample number 3. Limit of negative 3x minus 4 as x approaches 1/3. You have to separate and get their individual limits. Okay. So our constant limit of negative 3x as x approaches 1/3. Okay. I just put negative 3 outside in front of it, and then the same thing as limit of 4 as x approaches 1/3. So simplify negative 3, you copy the constant negative 3, and then limit of x as x approaches 1/3 give you 1/3 since our k is 1/3, and operation is minus. Limit of 4 as x approaches 1/3, since our function is 4 which is constant, simply copy it. Okay, 1/3 times negative 3 gives you negative 1, then copy negative 4. Negative 1 minus 4 is equal to negative 5. Let's proceed now to the fifth limit, which is the limit of product of a function. This is similar to the sum and difference of a function. In the limit of a product of a function, we have to remember that in evaluating the limit of product of functions, the following steps can be followed. First, express the limit in expanded form by applying the limit of a product theorem. Number 2, evaluate the limit of each function by applying the previously discussed limit theorems. And number 3, you have to simplify the resulting numbers. Okay, it says here that the limit of f of x times g of x as x approaches k is equal to limit of f of x as x approaches k times the limit of g of x as x approaches k. Let's have sample number 1. Limit of 3x times 5 as x approaches 1. Okay, so you separate both functions, f of x and the g of x, and then find the limit of each product. So limit of 3 of x as x approaches 1 times limit of 5 as x approaches 1. And then take note that there is a constant in the first function. That's why you have to move forward in front. That's why it turned out into 3. The limit of x as x approaches 1, and then simply copy limit of 5 as x approaches 1. Then do you remember the second theorem, which is limit of a function f of x? Okay, and then 3 times 1, and then limit of 5 as x approaches 1 is number 1 theorem, which is 5. Then 3 times 1 is 3. Then the product of 5 and 3 is 15. Therefore, the limit of 3x times 5 as x approaches 1 is 15. Okay, as you notice, there are some theorem that is being used. So please bear with that theorems. Sample number 2. Limit of 2x plus 1 times x plus 5 as x approaches negative 2. The same as number 1, you separate the two functions. It became limit of 2x plus 1 as x approaches negative 2 times the limit of x plus 5 as x approaches negative 2. Simplify first each function. So the first function is 2x plus 1. When you simplify it, it becomes negative 3. And then the other function is 3. And when you multiply negative 3 by 3, it gives us negative 9. So the limit of 2x plus 1 times x plus 5 as x approaches negative 2 is 9. Number 3. Limit of x plus 1 times negative 5 as x approaches negative 3. So the same thing as number 1 and number 2, separate each function. So it became limit of x plus 1 as x approaches negative 3, and the other function, limit of negative 5 as x approaches 3, then simplify. The first function gives us negative 2. The simplest form of the second term is negative 5. So negative 2 times negative 5, it gives us 10. Therefore, the limit of x plus 1 times negative 5 as x approaches negative 3 is 10. Number 6 theorem, limit of quotient of function, says that the limit of a quotient of a function is equal to the quotient of the limits of the individual function, provided that the denominator limit is not equal to 0. You have to remember that in evaluating the limit of a quotient of functions, the following steps can be followed. First, express the limit expanded form by applying the limit of product rule, but this time it is quotient rule. And then number 2, evaluate the limit of each function by applying the previous discussed limit theorems. And number 3, you have to simplify the resulting number. Okay. In symbol, limit of f of x over g of x as x approaches k is equal to limit of f of x as x approaches k all over limit of g of x as x approaches k. It's like you separate both function, numerator and denominator, provided that g of x must not equal to 0. Take note of that. Sample number 1. Limit of x all over 2 as x approaches 5. Separate numerator by denominator, then get the limit. So, limit of x as x approaches negative 5 in the numerator, the denominator, limit of 2 as x approaches 5. Take note that the numerator is theorem number 2, and then the denominator is theorem number 1. Then simplify the numerator, give us 5, and simplifying the denominator, it gives us 2. So, the limit of x all over 2 as x approaches 5 give us 5 half. Problem number 2. Limit of 3x all over 2 as x approaches negative 6. Okay, so you have to separate the numerator and denominator. But in here, we have constant 3. That's why I move it in front of the limit. So we can move fast in the solution. So 3 times the limit of x as x approaches negative 6 all over limit of 2 as x approaches negative 6. So simplify the numerator, it gives us 3 times negative 6. Remember the second theorem. Okay, and then denominator, it gives us 2. Remember that is number 1 theorem. So 3 times negative 6 gives us negative 18. And copying the denominator. And what is negative 18 divided by 2? It gives us 9. Therefore, the limit of 3x all over 2 as x approaches negative 6 is negative 9. The third example, limit of x plus 5 all over 3x minus 2 as x approaches 2. So we have to separate the numerator and denominator. So limit of x plus 5 as x approaches 2, the numerator, denominator, the limit of 3x minus 2 as x approaches 2. Okay, take note that there are some previous theorem that is being used. So we do a lot of techniques in here so we can provide the answer. So separate the x and 5, the numerator, and 3x with negative 2 in the denominator. So theorem number 2, the first term, then the second term is limit of 5 as x approaches 2, it's number 1 theorem. So when you simplify the numerator, that is 2 plus 5, it's give us 7, and then 3, since we have a constant 3 here, we move that in front of that limit, and then simplify. 3 times 2 give us 6, minus 2 is 4. And then the limit of x plus 5 all over 3x minus 2 as x approaches 2 is 7, 4. Okay, let's move now to theorem number 7, which is limit of power of function. This theorem states that the limit of an integer power n of a function is just the power of the limit of the function. In symbol, limit of f of x to the nth power x approaches k is equal to the nth power of limit of a function x as x approaches k. Okay. It's like you move to the second theorem. Example number 1. Limit of x raised to 4 as x approaches 2. So simplify that. It gives us the 4 became the power of the function. And then it moves to number 2 theorem. The limit of x as x approaches 2 give us 2. And to simplify 2 raised to 4 give us 16. Therefore, the limit of x raised to 4 as x approaches 2 is 16. Sample number 2. Limit of x squared plus 2 as x approaches negative 9. Okay, take note of this that sometimes there are combination of those the previous theorems. So please bear with the operation involved in here. In this sample, there is an operation between the function, which is addition. So you have to get the limit of both functions. Okay, let's have the first term. Limit of x raised to 2 as x approaches negative 9 plus, since that is addition, limit of 2 as x approaches negative 9. Then simplify the first function. And the nth power of limit of x as x approaches negative 9. So this is theorem number 2. So give us negative 9 raised to 2, then cut it plus 2. Negative 9 squared is 81 plus 2, it gives us 83. Therefore, the limit of x squared plus 2 as x approaches negative 9 is 83. Last sample. Limit of 3x raised to 4 plus 9x raised to 2 as x approaches negative 3. To separate the two terms but in addition theorem. Okay, limit of 3x raised to 4 as x approaches negative 3. And then as you notice, since we have a constant 3 in here, I move it forward and then proceed to the theorem number 8. Right, 7. The same as the second term, 9 is the constant, that's why I move it in front, and then simplify. So limit of x as x approaches 3 is negative 3, the same thing as the second term. And then simplify. 3 times negative 3 raised to 4 give us 243, and then the second term, 9 times square of negative 3 give us 81. Sum up, 243 plus 81 give us 324. Therefore, the limit of 3x raised to 4 plus 9x squared as x approaches negative 3 is 324. And for the last theorem, we have limit of root of a function. In some other books, this one is the limit of radical theorems. But this time, I'm going to use the root of a function. Okay, so the definition is, in this theorem states that if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of a function, provided that the n root of a function is a real number. Thus, it is important to keep in mind that if n is even, the limit of a function must be positive. In symbol, limit of the nth root of f of x as x approaches k is equal to the nth root of the limit of a function f of x as x approaches k, provided that the limit of a function is greater than 0 when n is even. I hope you understand that. So for you to understand that definition, let's have an example. Limit of square root of x as x approaches 8. Okay, so since we have square root of this way we squared the whole function, square root of limit of f of x as x approaches 8. And then take note of this because this is theorem number 2, limit of a function x. Then simply substitute, our k here is 8, and then the square root of 8, simplest form is 2 square root of 2. Therefore, the limit of square root of x as x approaches 8 is equal to 2 square root of 8. It is important also to simplify the given. So you must review those radicals, sometimes fractions, to be able to simplify the result. Sample number 2. Limit of 3x times square root of x as x approaches 27. So it's becoming more complicated because we combine the product and the root of a function. So on that, since we have the product, separate each function, then get the limit, and then since we studied in the previous theorem, so we're going to use it. Okay, separate 3x by square root of x. So limit of 3x times as x approaches 27 times limit of square root of x as x approaches 27. And then we just simplify it. The 3 move front, and then here number 2, then 3 times 27 times square root of 27. And then take note that 3 times 27 is 81. And then the simplest form of square root of 27 is 3 square root of 3. When you multiply 81 to 3 square root of 3, give us 243 square root of 3. Therefore, the limit of 3x square root of x as x approaches 27 is 243 square root of 3. Don't forget to simplify. Okay? Number 3. Limit of square root of 3x square minus 2x plus 8 as x approaches 2. So it became more complicated, but the thing here is that you must know the previous theorem that I discussed. Okay, in here, first step is that you're going to use the root of a function to get the limit. And then we have an operation involved, sum and difference. That's why you have to separate all those functions. Okay. Take note, in the solution, we have to square root all the terms, all the functions, and then distribute it, then get the individual limits. Okay. The limit of 3x squared as x approaches 2 minus 2 limit of x as x approaches 2 plus limit of 8 as x approaches 2. To simplify, give us 12 minus 4 plus 8, which is 16. Therefore, limit of square root of 3x squared minus 2x plus 8 as x approaches 2 is 16. I hope you understand the topic today. If you have questions, don't forget to comment down below. Thank you for watching.